Welcome to Exploration of Basic Mathematics.
Trigonometry. Part 8. Heights and distances.
We will be learning how to use trigonometry for measuring heights and distances of the objects far from us through the angle of elevation and the angle of depression.
Also, we will explain with 20 typical solve problems. The last problem, number 20, is a challenge. Before we start, we recollect some basics formulas of trigonometry. A revision of useful trigonometry's formulas.
A triangle is a closed shape figure in a plane with 3 angles, 3 sides, and 3 vertices. In a right-angled triangle, one angle is right angle, that is 90 degrees. The angle A and the angle B are complementary, as angle A plus angle B equals 90 or angle A equals 90 minus angle B. To draw a specific right-angled triangle, one must know at least one side of the triangle, along with angle A.
The side opposite to right angle C is the longest side, and it is called the hypotenuse. Other 2 sides are termed as the opposite and the adjacent to angle A. For angle B, the opposite and the adjacent are interchanged. The side CA is the opposite and the side BC is the adjacent to angle B. Trigonometric ratios and functions. Trigonometrical ratios are sine, cosine, and tangent. In short, we write them as sine, cos, and tan. Sine is defined as sine A equals opposite divided by hypotenuse. Cosine is defined as adjacent, divided by, hypotenuse. And tangent of A is defined as opposite, divided by, adjacent. There are 6 possible ratios. Other 3 are cosecant, CSC, secant, sec, and cotangent, cot. Cosecant or cosec of A is defined as hypotenuse, divided by, opposite. Secant, sec, of A is defined as hypotenuse, divided by, adjacent. Cotangent of A is defined as adjacent, divided by, opposite. With the help of sine, cosine and tangent, any side of the right-angled triangle, adjacent, opposite and hypotenuse can be calculated using following form. Opposite equals hypotenuse multiplied by sine of A. Adjacent equals hypotenuse multiplied by cosine of A. Opposite equals adjacent multiplied by tangent of A. We will also recollect some of the trigonometric identities, starting from Pythagorean identities. As we know that Pythagoras' theorem states, in a right-angled triangle, the square on the hypotenuse equals the sum of the squares on the other 2 sides. In a right-angled triangle, if the opposite side is A, the adjacent is B, and the hypotenuse is C, then as per Pythagoras' theorem, AE squared plus B squared equals C squared. Quick revision of Pythagoras' identities. Starting from A squared plus B squared equals C squared, we can derive 3 identities as follows. By dividing this equation, A squared plus B squared equals C squared by C squared, as A divided by C equals sine A and B divided by C is cosine A. So we get square of sine AE plus square of cosine A equals 1. Starting from A squared plus B squared equals C squared, we derive an identities as follows. By dividing this equation by B squared, as A by B equals tangent of A and C by B is secant of A, so we get square of tangent of A plus 1 equals square of secant AE. Starting from A squared plus B squared equals C squared, we derive third identities as follows. By dividing this equation by A squared, as B by A equals cotangent A and C by A is cosec A, so we get 1 plus square of cotangent A equals square of cosecant A. Here is summary of all Pythagoras' identities. Square of sine AE plus square of cosine A equals 1. Square of tan AE plus 1 equals square of secant AE. 1 plus square of cotangent AE equals square of cosecant AE. We remind you sign rules. Sign in a triangle. Draw a triangle ABC with all angles as acute angle and the side A, opposite to the angle A, the side B, opposite to the angle B, and the side C, opposite to the angle C. This order of labeling is important. Triangle sign rule, which is same for all triangles, is A divided by sign of A equals B divided by sign of B equals C divided by sign of C. We remind you cosine rules. Cosine in a triangle. A squared equals b squared plus c squared minus 2 times b multiplies by c and cosine of A. Or cosine of A equals b squared plus c squared minus a squared over all divided by 2 times b multiplied by c. Cosine formula is true for every triangle ABC, whether angle A is acute or obtuse. But remember, if angle A is obtuse, the value of cos is negative. Here is summary for cosine of all angles of the triangles. A squared equals b squared plus c squared minus 2 times b multiplies by c and cosine of A. And so on. We learned some terms like line of sight, angle of elevation and angle of depression before we start discussing the problems of height and distance in trigonometry. Angle of elevation. When we see an object above the horizontal level, then the angle formed by the line of sight above the horizontal is known as angle of elevation. Angle of depression. When we see an object below the horizontal level, then the angle formed by the line of sight below the horizontal is known as angle of depression. Subtended angle is an angle between two lines of sight at two ends of an object. To understand it better, we solve some practical problems.
Problem 1. An observer standing on the edge of a cliff, 100 m above the sea level, sees a ship at angle of depression of 20 degrees. How far from the base of the cliff is the ship situated? After learning the problem you are going to solve, we advise you to imagine the scenario on the ground and then draw a line diagram of an equivalent right-angled triangle to represent this situation.
Remember, generally, the hypotenuse of the right-angled triangles represents the line of sight, the opposite of the right-angled triangles represents the height, and the adjacent of the right-angled triangles represents the distance. Convert this picture into simple geometry, correcting 3D triangle to 2D triangle. Let the ship be at point S, x meter from the base of the cliff at B. The observer person is standing 100 meters above sea level at the point P and is looking at horizontal point H and sees a ship at angle of depression of 20 degrees. Now in a right-angled triangle PBS, the angle PSB is 20 degrees. So the tangent of 20 degrees equals PB divided by BS equals 100 divided by x. Or x equals 100 divided by tangent of 20 degrees. From the tables of trigonometry data or scientific calculator you can read the value of the tangent of 20 degrees, which is 0.364. Therefore x, or the ship, is equals 274.7 meters away. Problems number 2. The angle of elevation of the top of the tower from a point on the same level as foot of the tower is 30 degrees. The distance from the point to the base of the tower is 150 meters. Find the height of the tower. Convert this picture into simple geometry with correction of 3D triangle to 2D triangle. Or you can visualize another way. In the triangle OTB, tangent of the angle TAB equals TB divided by BA. Or tangent of the angle 30 degrees equals H divided by 150. Or H equals 150 multiplied by tangent of 30 degrees. As the tangent of 30 degrees equals 1 divided by under root 3 is equal to 0.577. or h equals 86.6, or the height of tower is 86.6 meters.
Problems number 3. The angle of depression. From the roof of a building P to the foot of the second building R, across the same street, 40 meters away is 65 degrees. The angle of elevation of the roof of building R to the roof of building P is 35 degrees. How tall is the building R? After learning the problem, we advise you to imagine the scenario on the ground. Two buildings are P and R. P is taller than R. Base of the buildings are A and B. Let C is a point, which is horizontal to the top of the building R. Bases of the buildings A and B are 40 meters away and are on same line. So AB equals 40 meters. Also RC equals 40 meters. Let the height of building P is X and that of building R is Y. We will find out the Y. In the triangle CPR, tangent of the angle PRC equals PC divided by RB, or tangent of 35 degrees equals PC divided by RB, or equals x minus y divided by 40. So y equals x minus 40 times tangent of 35 degrees. In the triangle APB, tangent of the angle PBA equals PA divided by AB, or tangent of 65 degrees equals x divided by 40. Put this value of x in the equation y equals x minus 40 times tangent of 35 degrees. So we have y equals 40 times tangent of 65 degrees minus 40 times tangent of 35 degrees. As we learn, tangent of 35 degrees equals 0.7 and tangent of 65 degrees equals 2.14. Therefore y equals 57.77. The height of building R is 57.77 meters.
Problems number 4. A person standing on the bank of a river observes that the angle subtended by a tree on opposite bank is 60 degrees. When he retreats 40 meters from the bank of the river, he finds the angle to be 30 degrees. Find the height of the tree and width of the river. Now imagine the scenario on the ground, and then draw a line diagram of an equivalent right-angled triangle to represent this situation. Let the height of the tree equals h. And width of the river equals x. All distances are in meters. In the triangle TBA, tangent of the angle TAB equals TB divided by BA. Or tangent of 60 degrees equals h divided by x. As tangent of 60 degrees equals under root 3. Or under root 3 equals h divided by x. So x equals h divided by under root 3. Note in the triangle TBC, tangent of the angle TCB equals TB divided by BC. Or tangent of 30 degrees equals h divided by x plus 40. As tangent of 30 degrees equals 1 divided by under root 3. Further you see that x plus 40 equals under root 3 times h. Put this value of x, that x equals h divided by under root 3, in the equation. X plus 40 equals under root 3 times h. We have under root 3 times h minus h divided by under root 3 is equal to 40. Multiply all by under root 3. So by multiplying all by under root 3, and further simplifying it, we get h equals 34.64, and x equals 20. Therefore, the height of the tree equals 34.64 m, and width of the river equals 20 m. Problems number 5. The angle of elevation of the top of the tower from a point on the same level as foot of the tower is 30 degrees on advancing 150 meters towards the foot of the tower. The angle of elevation increases to 60 degrees. Find the height of the tower.
After learning the problem, we advise you to imagine the scenario on the ground, and then draw a line diagram of an equivalent right-angled triangle to represent this situation. Let the height of the tree equals h. In the triangle TBA, tangent of the angle TAB equals TB divided by BC plus CA, or tangent of 30 degrees equals h divided by x plus 150. X plus 150 equals under root 3 times h, as tangent of 30 degrees equals 1 divided by under root 3. Note in the triangle TBC, tangent of the angle TCB equals TB divided by BC, or tangent of 60 degrees equals h divided by x, as tangent of 60 degrees equals under root 3, or x equals h divided by under root 3. Put this value of x, that x equals h divided by under root 3, in the equation. X plus 150 equals under root 3 times h. We have under root 3 times h minus h divided by under root 3 is equal to 150. Multiply all by under root 3. We get h equals 129.9. The height of the tower equals 129.9 meters. Alternate solution. Now look at this figure differently. Note, the angle of depression from point T, from top of tower to point A is 30 degrees, and to point C it is 60 degrees. So the angle ATC equals 30 degrees. Note, the triangle TCA is an isosceles triangle. So the sides AC equals CT equals 150 meters. Now in the triangle TCB, the sine of the angle TCB equals TB divided by TC, or sine of 60 degrees equals h divided by 150, as sine of 60 degrees equals under root 3 divided by 2. So h equals 75 under root 3. Again we found the same answer, that the height of the tower equals 129.9 meters.
Problems. Number 6. Find the height of a tower. When it is found that on walking towards it, 100 meter in horizontal line, through its base, angular elevation of its top changes from 30 degrees to 45 degrees. Now imagine the scenario on the ground, and then draw a line diagram of an equivalent right-angled triangle to represent this situation. Let the height of the tower equals h, and distance from C to B equals x. In the triangle TBA, tangent of the angle TAB equals TB divided by AC plus CB, or tangent of 30 degrees equals 100 plus h divided by x, as tangent of 30 degrees equals 1 divided by under root 3, or 100 plus x equals under root 3 times h. Note in the triangle TBC, tangent of the angle TCB equals TB divided by BC, or tangent of 45 degrees equals h divided by x, as tangent of 45 degrees equals 1. Therefore, x equals h. Solving it further, by replacing x by h, we get h equals 136.6. The height of the tower equals 136.6 meters. Problems number 7. A man on the cliff observes a boat at an angle of depression of 30 degrees, which is sailing towards the shore to the point immediately beneath him. 3 minutes later, angle of depression of boat is found to be 60 degrees, assuming that both sails at a uniform speed. Determine how much time it will take to reach the shore. Imagine the scenario on the ground, and then convert this picture into simple geometry. Let the speed of the boat equals s per minute, as it takes 3 minutes to reach from A to C. The distance of A to C equals 3 times s, and the distance the boat has to cover is x times s, let's say in x minutes. So we have to find out x. Also, let's assume the height of the cliff equals h. In the triangle TBA, tangent of the angle TAB equals TB divided by BC plus AC. Or tangent of 30 degrees equals h divided by xs plus 3 times s. Or 1 divided by under root 3 equals h divided by s times x plus 3s. As tangent of 30 degrees equals 1 divided by under root 3. Now in the triangle TBC, tangent of the angle TCB equals TB divided by BC. Or tangent of 60 degrees equals h divided by xs. Or x equals h is divided by under root 3 times s. As tangent of 60 degrees equals under root 3. Solving it further by replacing h divided by s in the equation. 1 divided by under root 3 equals h divided by s times x plus 3s. We get x equals 3 divided by 2. Therefore, the time the boat will take to reach the shore is 1.5 minutes.
Problems. Number 8. On level ground, the angle of elevation of the top of a tower is 30 degrees. On moving 20 meters nearer, the angle of elevation is 60 degrees. Find the height of the tower. Imagine the scenario on the ground, and then convert this picture into simple geometry. In the triangle TBA, tangent of the angle TAB equals TB divided by AC plus BC. Or tangent of 30 degrees equals H divided by 20 plus X. As tangent of 30 degrees equals 1 divided by under root 3. We have 20 plus X equals under root 3 times H. Now, in the triangle TBC, tangent of the angle TCB equals TB divided by BC. Or tangent of 60 degrees equals H divided by X. Or X equals H is divided by under root 3. As tangent of 60 degrees equals under root 3. Solving it further by replacing X equals H is divided by under root 3 in the equation. In 20 plus X equals under root 3 times H. Simplifying it, we get H equals 17.32. Therefore, the height of the tower equals 17.32 meters. Problems. Number 9. An aeroplane flying horizontally, 1 kilometer above the ground, is observed at an angle of elevation of 60 degrees. If after 10 seconds, the elevation is observed to be 30 degrees, find the uniform speed per hour on the ground of the plane. Imagine the scenario on the ground, and then convert this picture into simple geometry. Let speed of the plane equals s km per second. So PQ equals 10 times s in kilometer, and note all distances are in kilometer. Also BC equals 10 times s. And PB equals QC equals 1. Let AB equals x. In the triangle PBA, tangent of the angle PAB equals PB divided by AB. Or tangent of 60 degrees equals 1 divided by x. We have x equals 1 is divided by under root 3. As tangent of 60 degrees equals under root 3. Note in the triangle AQC, tangent of the angle QAC equals QC divided by AC. Or tangent of 30 degrees equals 1 divided by x plus 10s. As tangent of 30 degrees equals 1 divided by under root 3. Or x plus 10s equals 1 is divided by under root 3. Solving it further by replacing x equals 1 divided by under root 3. In x plus 10s equals under root 3 times h. Multiply both sides by square root 3. We get s equals 1 is divided by 5 multiplied by under root 3. To calculate speed per hour, we multiply by 3600, as 1 hour equals 3600 seconds. So we get the speed per hour on of the plane is 415.7 kilometers per hour. Problems. Number 10. The angle of elevation of the top of the tower from a point A on the same level as foot of the tower B is 30 degrees. On moving towards the foot of the tower passing it to other side of the tower at point C, the angle of elevation is 60 degrees. Points A, B, and C are in horizontal line, and the distance between A and C is 200 meters. Find the height of the tower. Imagine the scenario on the ground, and then convert this picture into simple geometry. Let AB equals x. In the triangle TBA, tangent of the angle TAB equals TB divided by AB, or tangent of 30 degrees equals h divided by x. As tangent of 30 degrees equals 1 divided by under root 3, we have 1 divided by under root 3 equals h divided by x, or x equals under root 3 times h. Note in the triangle TBC, tangent of the angle TCB equals TB divided by BC, or tangent of 60 degrees equals h divided by 200 minus x, as tangent of 60 degrees equals under root 3. So we have h equals under root 3 times 200 minus x. Solving it further by replacing x equals under root 3 times h in h equals under root 3 times 200 minus x, we get h equals 173.2, or the height of the tower equals 173.2 meters.
Problem. Number 11. The shadow of a tower is standing on a level ground, is found to be 60 meters longer, when the sun altitude is 30 degrees, then when it is 45 degrees. Find the height of the tower. Imagine the scenario on the ground, and then convert this picture into simple geometry. Note A, B equals 60 and let C, B equals x. In the triangle TBA, tangent of the angle TAB equals TB divided by AB. Or tangent of 30 degrees equals h divided by 60 plus x. As tangent of 30 degrees equals 1 divided by under root 3. We have 1 divided by under root 3 equals h divided by 60 plus x. Or x plus 60 equals under root 3 times h. In the triangle TBC, tangent of the angle TCB equals TB divided by BC. Or tangent of 45 degrees equals h divided by x. As tangent of 45 degrees equals 1. We have x equals h. Solving it further by replacing x equals h. In x plus 60 equals under root 3 times h. Simplifying it and calculating. We get h equals 81.96. Therefore, the height of the tower equals 81.96 meters.
Problem number 12. A man in a boat, rowed away from cliff, 150 meter high, takes 2 minutes to change angle of elevation of the top of the cliff from 60 degrees to 45 degrees. Find the speed of the boat. Imagine the scenario on the ground, and then convert this picture into simple geometry. Note AC equals 2s, where s equals speed of the boat and let AB equals x. Note in the triangle TBA, tangent of the angle TAB equals TB divided by AB. Or tangent of 60 degrees equals h divided by x. As tangent of 60 degrees equals under root 3. Or under root 3 times equals 150 divided by x. Or x equals 150 divided by under root 3. In the triangle TBC, tangent of the angle TCB equals TB divided by BC, or tangent of 45 degree equals 150 divided by x plus 2s. As tangent of 45 degrees equals 1. We have x plus 2s equals 150. Solving it further by replacing x equals 150 divided by under root 3. In x plus 2 times s equals 150. We get 2 times s equals 150 minus 150 divided by under root 3. Therefore s equals 31.7. So the speed of the boat equals 31.7 meters per minute. Problem number 13. From an aeroplane, vertically over a straight horizontal road, the angle of depression of 2 consecutive milestones on opposite side are observed to be alpha and beta. Show that the height in miles of the aeroplane above the road is given by tangent of alpha times tangent of beta divided by tangent of alpha plus tangent of beta.
Imagine the scenario on the ground, and then convert this picture into simple geometry. Note AC equals 1 mile, and let height TB equals h. Also let AB equals x and BC equals y, such that the sum of x and y equals 1. Now in the triangle TBA, tangent of the angle TAB equals TB divided by AB, or tangent of alpha equals h divided by x, or x equals h divided by tangent of alpha. Note in the triangle TBC, tangent of the angle TCB equals TB divided by BC, or tangent of beta equals h divided by y, or y equals h divided by tangent of beta. So x equals h divided by tangent of alpha and y equals h divided by tangent of beta. As the sum of x and y equals 1, so we have 1 equals h divided by tangent of alpha plus h divided by tangent of beta. Simplifying it further, we have the height of the plane as tangent of alpha times tangent of beta divided by tangent of beta plus tangent of alpha, which is same as desired. Problem number 14. The angle of depression from the top of a building 60 meters high to swing in a local playground is 58 degrees. How far is the swing from the foot of the building? Imagine the scenario on the ground, and then convert this picture into a simple geometry. Note TB equals 60 meters, the angle TAB equals 58 degrees. Let AB equals x meters. Now in the triangle TBA, tangent of the angle TAB equals TB divided by AB, or tangent of 58 degrees equals 60 divided by x. Now read from calculators the value of tangent of 58 degrees, which is 1.6, or x equals 60 divided by 1.6. Therefore x equals 37.5. From the foot of the building, the swing is 37.5 meters far. Problem number 15. From a pointer on the ground, the angle of elevation to the top of tree is 52 degrees. If the tree is 14.8 meters away from a point, find the height of the tree. Imagine the scenario on the ground, and then convert this picture into a simple geometry. Note AB equals 14.8 meters, angle TA, B equals 52 degrees, and let T, B equals h meters. Now in the triangle TBA, tangent of the angle TAB equals TB divided by AB, or tangent of 52 degrees equals h divided by 14.8, or h equals 14.8 times tangent of 52 degrees. Read from calculators the value of tangent of 52 degrees, which is 1.28. Calculating it further, we have therefore h equals 18.9. So the height of the tree is 18.9 meters. Problem number 16. Find the angle of elevation from a bench on the top of an 80-meter high building. If the bench is 105 meter from the foot of the building, imagine the scenario on the ground, and then convert this picture into a simple geometry. Note AB equals 105 meters, TB equals 80 meters, and let angle TAB equals alpha degree. Now in the triangle TBA, tangent of the angle TAB equals TB divided by AB, or tangent of alpha equals 80 divided by 105, or tangent of alpha equals 0.7618. Read from calculators the value of tangent of 37.3 degrees is the closest to 0.7619. Therefore alpha equals 37.3 degrees. The angle of elevation from a bench is 37.3 degrees.
Problem number 17. A surveying team is trying to find the height of a hill they take a site on the top of the hill and find the angle of elevation is 23 degrees and 24 minutes. They move a distance of 250 meters on the level ground directly away from the hill and take a second site. From this point, the angle of elevation is 19 degrees and 42 minutes. What is the height of the hill? Imagine the scenario on the ground, and then convert this picture into a simple geometry. Note AC equals 250 meters. Angle TAB equals 19 degree 42 minutes and let TB equals H. In the triangle TBA, tangent of the angle TAB equals TB divided by AB. Or tangent of 19 degree 42 minutes equals H divided by 250 plus X. Tan 19 degree 42 equals 0.358. As read from scientific calculators. Or H equals 0.358 times 250 plus X. In the triangle TBC, tangent of the angle TCB equals TB divided by BC. Tangent of 23 degree 24 minutes equals H divided by X. Tangent of 23 degree 24 minute equals 0.433 as read from scientific calculators. Therefore X equals H divided by 0.433. Put this value of X now and we have H equals 0.358 multiplied by 250 plus H divided by 0.433. Solving it further, we get H equals 516.67, so the height of the hill is 516.67 meters.
Problems number 18. The angle of elevation of the top and the bottom of a flagstaff fixed at the top of the tower at a point distant x feet f from the foot of the tower are alpha and beta. Prove that the height of the flagstaff is x times tangent of alpha minus tangent of beta. Imagine the scenario on the ground and then convert this picture into simple geometry. Note AB equals x feet and let TC equals h and BC equals y. Given that angle TAB equals alpha. In the triangle TBA, tangent of the angle TAB equals TB divided by AB. Or tangent of alpha sad smiley h plus y divided by x. Or h plus y equals x multiplied by tangent of alpha. In the triangle ABC, given that angle TAB equals beta and let BC equals y. Tangent of the angle CAB equals CB divided by AB. Tangent of beta equals y divided by x. Or y equals x multiplied by tangent of beta. Solving it. H plus y equals x times tangent of alpha. By putting y equals x multiplied by tangent of beta, we have, finally, the required expression for the height of the flag staff. That is, x times tangent of alpha minus tangent of beta. Problems number 19. From the top of a spire, the angle of depression of the top and the bottom of a tower of height h are alpha and beta. Show that the height of the spire y and its horizontal distance x from tower r. Y equals h times the cosine of alpha and sine of beta divided by sine of beta minus alpha. X equals h times the cosine of alpha and cosine of beta divided by sine of beta minus alpha. Imagine the scenario on the ground, and then convert this picture into a simple geometry. Note the height of the spire PA is y. The height of the tower RB is h. Distance between them BA equals x. Angle PRC equals alpha and angle PBA equals beta. In the triangle PRC, tangent of the angle PRC equals PC divided by RC. Or tangent of alpha sad smiley y minus h over all divided by x. Or y minus h equals x multiplied by tangent of alpha. In the triangle PBA, tangent of the angle PBA equals PA divided by AB. Tangent of beta equals y divided by x. Or y equals x multiplied by tangent of beta. Solving it. H equals x times tangent of beta minus x times tangent of alpha. Now rewrite tangent of beta as sine of beta divided by cosine of beta and tangent of alpha as sine of alpha divided by cosine of alpha. Please remember, Since sine of beta times cosine of alpha minus sine of alpha times cosine of beta equals sine of beta minus alpha. So we have x equals h multiplied by cosine of beta and cosine of alpha divided by sine of beta minus alpha. Similarly, we solve for y by putting the value of x. We get the desired result. The height of the spire y equals h times the cosine of alpha into sine of beta divided by sine of beta minus alpha. And its horizontal distance x equals h times the cosine of alpha into cosine of beta divided by sine of beta minus alpha.
Problems number 20. An object is observed from 3 points A, B and C in the same horizontal line passing through the base of the object. The angle of elevation at B is twice and at C is thrice that of at A. If AB equals A, BC equals B, prove that the height of the object is A divided by 2 times B multiplied by under root of A plus B and 3 times B minus A. Imagine the scenario on the ground, and then convert this picture into simple geometry. Please note, height of the object equals h, distances AB equals A, CB equals B, and let QC equals x. Angle PAQ equals alpha. Angle PBQ equals 2 times alpha. Angle PCQ equals 3 times alpha. Note in triangle PQA, tangent of the angle PAQ tongue poking smiley Q divided by QA. Tangent of alpha dot equals h divided by x plus a plus b. Note in triangle PQB, tangent of the angle PBQ tongue poking smiley Q divided by UQB. Tangent of 2 alpha equals h divided by x plus b. Note in triangle PQC, tangent of the angle PCQ tongue poking smiley Q divided by QC. Tangent of 3 alpha equals h divided by x. Please note, the answer given in problem may be little difficult by solving only equations of tangents. We now look at the figure carefully and try to get some other clues. Note in triangle PBA, the angle PAB equals alpha, the angle PBA equals 180 minus 2 times alpha, and so the angle BPA equals alpha. Therefore the triangle PBA is an isosceles triangle and the sides AB equals PB equals A. Note in triangle PBC, the angle PBC equals 2 times alpha. The angle PCB equals 180 minus 3 times alpha. And the angle BPC equals alpha. Now in triangle PBQ, the angle PBQ equals 2 alpha, the side PB equals A. So the sine of 2 times alpha equals PQ divided by PB. Or sine of 2 times alpha equals H divided by A. As sine of 2 times alpha equals 2 times sine of alpha multiplied by cosine of alpha. Or H equals 2 times A multiplied by sine of alpha and cosine of alpha. In the triangle PBC, note the sides and the angles as in figure. In triangle PBC, we will apply the sine rule, that is, AE divided by sine of A equals B divided by sine of B equals C divided by sine of C. Or in triangle PBCB divided by sine of alpha equals A divided by sine of 3 alpha. As sine of 180 minus 3 alpha equals sine of 3 alpha. Now solve equations further and we get AE divided by B equals sine of triple alpha divided by sine of alpha. As we know, sine of triple alpha equals 3 times of sine of alpha minus 4 times cube of sine of alpha. Solving it further, we have square of sine of alpha equals 3 times B minus A overall divided by 4 times B. Remember the Pythagoras identity, that is, the square of sine alpha plus the square of cosine of alpha equals 1. We can calculate the square of cosine of alpha as B plus A divided by 4 times B. Now we have both sine and cosine of alpha, which we can put in. H equals 2 times A multiplied by sine of alpha and cosine of alpha. Solving it further, follow the steps as shown, we get required form of answer. That is, the height of the object is A divided by 2 times B multiplied by under root of A plus B and 3 times B minus A. That is it. We hope you enjoyed the problems of height and distance. There may be some typo mistake. If you notice them, write it in your comment. You may continue to watch our videos. If you missed our earlier video, you can get from this channel. Thank you very much for watching it.